This video is about applying the properties of a trapezoid and an isosceles trapezoid. So trapezoids and isosceles trapezoids are different from the other shapes that we have talked about so far. So they are not related to a parallelogram, rectangle, rhombus, or square. This is because a trapezoid has exactly one pair of parallel sides. So over here we're going to have one set of parallel sides. Our base of the trapezoid are the parallel sides. So we're going to have two bases here. The legs then are the non-parallel sides. So we also have two legs. So we're only always going to have one parallel side and one not parallel side. The base angles then are angles formed by a base and leg. Now we have two sets of base angles here. These are base angles up here, and they're on the top, so these are going to be our upper base angles. And then we have angles on the bottom here for the lower base, and those are going to be lower base angles. A trapezoid only has two properties. One property is that the sides are parallel, and then because the sides are parallel, our consecutive angles, one from each base, is going to be supplementary, which should make sense here because if we have two parallel sides, these angles are same side interior angles, so they are going to be supplementary. They're not always going to be the same though. So for example, this could be 100, this could be 80, this could be 120, and this could be 60. So you could have four different angle measurements here. So we're going to use the consecutive angles, one from each base, are supplementary to solve for x and y. So if our parallel sides are A, B, and CD, this is one set of supplementary angles, and this is a second set of supplementary angles. So we have 2x plus 25 plus 3x plus 15 is equal to 180. So as we solve for x here, we have 5x plus 40 is equal to 180. 5x is equal to 140. So when we divide, we get x is 28. We also have then that 88 plus 10y minus 2 is equal to 180. So we get 10y plus 86 equals 180. 10y is equal to 94. So when we divide here, we're not going to get a whole number, so we're going to rewrite that as a fraction. 49 divided by 10 comes out to 47 fifths. In number 2, we want to solve for x and y. So again, we have our parallel sides. These angles are going to be supplementary with each other. So we have 3x plus 9y plus 90 is equal to 180. We can move over the 90, so we get 3x plus 9y equals 90. And then we have 5x plus 3y plus 114 is equal to 180. And we subtract 5x plus 3y is equal to 66. So we have two equations. That we can use to solve for our variable. So I'm going to multiply the second equation by -3. So we get 3x plus 9y is equal to 90. And -15x minus 9y is equal to -198. When we add straight down, -12x is equal to -108. So when we divide, x is 9. Once we know x is 9, we have to substitute to get our other variable. So 3 times 9 plus 9y equals 90. 27 plus 9y equals 90. 9y equals 63. So y is 7. So we would have 9, 7 as our ordered pair. Now we're going to move into an isosceles trapezoid. So an isosceles trapezoid is going to add some extra properties that we can use to solve with. So in an isosceles trapezoid, we still have the bases that are parallel, but now the non-parallel sides, which are the legs, are congruent. So the legs are going to have the same length. So think of an isosceles trapezoid kind of like an isosceles triangle, but instead we have two bases. So the properties of an isosceles trapezoid then are that the legs are congruent. Each pair of base angles are congruent. So if they're on the same base, they are going to be congruent to each other. So A is congruent to B and C is congruent to D. And we have that the full length of the diagonals are congruent. So let's use these properties to solve. So number 3, we want to find the missing angles. Well, here we turned the isosceles triangle on its side, so our bases are actually on the side instead of top and bottom this time. So C and D are on the same base. They're going to have the same angle measurement. And then B and A are going to be congruent. So we know from a regular trapezoid that the base angles, one from each base, are supplementary. So we can do 180 minus 100 to get that our other two angles are 80 degrees. In number 4, we want to solve for x. So we know that P and O are on the same base. So we can set those equals. 6x plus 6 equals 5x plus 18. So we get x equals 12. Once we know x is 12, we can substitute. So 6 times 12 plus 6 gets us that angle P and angle O are 78 degrees. 10 times 12 minus 18 gets us that M and N are both 102 degrees because those are going to be congruent since they're on the same base. Number 5, AC, this whole diagonal, is x squared plus 5x, and this whole diagonal BD is 2x plus 18. AB is 7y minus 2, and CD is 26. So if we're solving for x, we know that the diagonals are congruent. X squared plus 5x equals 2x plus 18. We can move everything to the x squared side. So x squared plus 3x minus 18 equals 0. We need two numbers that multiply to negative 18 and add to 3. So we have x plus 6 and x minus 3 equals 0. When we switch our signs, x is negative 6 and x is 3. Both of these would work as solutions. We also know that our legs are congruent. So we have 7y minus 2 is equal to 26. 7y equals 28. So when we divide, y is 4. The last part that we're going to talk about then is a mid-segment of a trapezoid. So we have talked about mid-segments of triangles before. This follows along the same idea. So a mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the leg. The mid-segment of a trapezoid is parallel to each base, so all three of these are parallel. And the length of the mid-segment of a trapezoid is half the sum of the bases. So our mid-segment is equal to 1/2 base 1 plus base 2. So, number 6, solve for x and y. So we know that this leg here is bisected. So if 7 is this length, y is also going to equal 7. To solve for x, our mid-segment is the middle segment, so that's going to go by itself. 2x plus 6 is equal to half of the bases added together, so 13 plus 31. 2x plus 6 is equal to half of 44. So 2x plus 6 equals 22. 2x equals 16. So x is 8. In number 7, CD is a mid-segment. Solve for x and y. So again, our mid-segment is 4x plus 10. That's going to equal half of our bases together. 3x plus 8 plus 6x. So we get 4x plus 10 is equal to 1/2 9x plus 8. Now, I don't want to distribute the half because then I have to deal with a fraction. So instead, I'm going to multiply both sides by 2, so that cancels out the half, and it doubles this other side. So 8x plus 10 is equal to 9x oops, sorry, 8x plus 20 is equal to 9x plus 8. So we would get x equals 12. To solve for y, d is going to be a midpoint, so it splits that side in half. 5y minus 2 equals 23. 5y equals 25. So y is 5.